Hello guys, today I have a cool question that is derive Euler's formula. So since we know the Euler's formula is e to the power I theta is equals to cos theta plus I sin theta. And now to derive this formula, we have to know the series expansion of e to the power x. And since the e to the power x can be expanded as 1 plus x by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial plus so on up to infinite, where x is any real number. Here we are going to use this series expansion to derive the Euler's formula. Here what we have to do, we just need to do it is we have to substitute I theta in case of x, then we will get the result of Euler's formula, this one, e to the power I theta equals to cos theta plus I sin theta. So before substituting I theta in case of x, we have to know another some trigonometric series expansion for cos x and sin x. So how it looks like, this is cos x can be written as 1 minus x squared by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial plus so on. And for sin x we can write 1 minus x cubed by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial plus so on up to infinite. So we are going to use this to expansion. Now let's rewrite again this series. So then we get e to the power x is equals to 1 plus this one, x by 1 factorial plus x squared by 2 factorial plus so on up to infinite. So let's substitute x is equals to I theta in case of x is equals to I theta, where I means the imaginary unit here, and theta is some angle. Okay, and now just we are going to substitute in place of x. So then e to the power I theta 1 plus I theta divided by 1 factorial plus I theta whole square divided by 2 factorial plus I theta whole cube divided by 3 factorial plus so on. And now we need to know if we take power of imaginary unit, then okay, what is the result of it? Since we know that in complex number system, so since I means square root minus 1, and if we take I squared, then we'll get minus 1, and if we take I cubed, then it will be minus I, and if we take I to the power 4, then it will be plus 1, and if we take I to the power 5, then it will be going to plus I. Okay, now e to the power I theta, that will be becomes 1 plus I theta, and since I square means minus 1, so then we'll get minus theta squared by 2 factorial, and I cubed means it is minus I, then minus I theta cubed divided by 3 factorial, and I to the power 4 means it is plus 1, so plus theta to the power 4 by 4 factorial, and plus again I to the power 5 means I, then I theta to the power 5 by 5 factorial plus so on, minus, it will be minus, so on. We'll get this. And now what we need here, just we need to arrange them in that way the real part will be in a group and the imaginary part will be in a group, in another group. So then let's arrange them. So let's collect the all real parts, this one, this one, and so on. We'll get many terms, but I'm not going to write those all. Okay, so 1 minus theta square by 2 factorial and plus theta to the 4 by 4 factorial and minus so on. And let's again grouping the whole imaginary terms so this is I theta and this one, then we'll get here I will be common out, so then this is I and left under bracket, so theta, and here minus theta cubed by 3 factorial and plus theta to the power 5 by 5 factorial minus so on. Now we can relate this expansion with this cos x and sin x, because these expansions are nothing but the expansion of cos x and sin x. So first let's see this expansion. This expansion is similar with what? The expansion of cos x. So here we just have to substitute theta in case of x. That means the input is theta here, so we just have to write in case of x theta and plus I, and this expansion is similar with what? This sin x expansion. So we'll get sin, input is theta here, so sin theta. So finally we get the final result of Euler's formula. So this is our result. This is the Euler's formula, and we have done this. Thank you so much for watching. If you are new in this channel, then please like, share and subscribe, and stay tuned with our channel for more interesting math videos. Bye bye.